Hi everyone. The mission of cybersecurity giant Crowdstrike is to defend enterprises against attack. But when they pushed a single broken update, they actually became the reason that 8.5 million Windows computers across the world's biggest organizations all went offline. This incident highlights the risks of relying on a single provider, which is the norm in our current digital monoculture. As attackers gain more sophisticated capabilities from advanced AI, improving the security of our infrastructure will become increasingly critical. Keep watching to learn more. This video has 3 parts: what happened with Crowdstrike, under the hood, and addressing systemic risk. Part 1. What happened with Crowdstrike? Depending on your background, you may not have heard of Crowdstrike, but they're a $75 billion company that makes almost $1 billion in revenue every year. Crowdstrike is the single biggest provider of cybersecurity solutions to enterprises. They count more than half of the Fortune 500 amongst their clients. Their business consists mostly of deploying software to endpoints and having analysts watch attacks in real time, figure out what's happening, and push fixes to the rest of Crowdstrike's endpoints. In fact, this was the original rationale behind the name Crowdstrike, because they leverage the knowledge of the crowd. In other words, while this unlucky first victim is being attacked over here, everybody else can learn from that failure and quickly get patched. Of course, they're also a first-rate technical security solution. They're what's called an EDR, or Endpoint Detection and Response Tool. That's basically a superset of the capabilities that you would expect an antivirus to be able to do. EDR tools report their findings to the cloud, where there's often human analysts looking at that, looking for problems. So an EDR is typically a tool for larger organizations to use, not single-person businesses or personal computers. So why has Crowdstrike been in the news? Well, on Friday, July 19th, at 9 minutes past midnight Eastern Time, Crowdstrike pushed a bad update to their Windows clients. And remember, their clients are large enterprises, so they tend to use quite a lot of Windows systems. Crowdstrike also runs on macOS and Linux, and there are some indications that the bad update may have affected Linux as well, but the only thing people are focusing on is the Windows machines, because the same update was pushed to every single Crowdstrike installation at the same time. The result is that about 8.5 million machines all got bricked at exactly the same time. 8.5 million is just a guess right now, but it's Microsoft's best estimate of how many machines were affected. If 8.5 million sounds like a lot, that's because it is. The next largest single cyber event was WannaCry in 2017, and that impacted around 300,000 computers. That's why this current situation with Crowdstrike is probably the biggest cyber incident ever. To be clear, this was not a cyber attack, it was just an accident, but nevertheless, it impacted 8.5 million computers. Furthermore, the machines that Crowdstrike was protecting were disproportionately very important. They were running a lot of critical infrastructure, because Crowdstrike is only used by larger companies. In fact, their license count minimum is 50. You have to buy at least 50 licenses from them, and it tends to be quite expensive. Fortunately, the Windows machines were not bricked permanently, but the fix does require someone to physically come to the machine, boot it into safe mode, and delete a file, which is very hard to do at scale across thousands of machines. So although it might just seem like a bit of an annoyance, it's actually had a really large economic impact. Here are some examples. You've probably seen pictures of airports coming to a virtual standstill. Often, passengers couldn't check into their flights, and some even received handwritten boarding passes. Nearly all airplanes in the United States were grounded. United and Delta had their systems completely taken offline, so they were grounded immediately. And then the US aviation authorities decided to err on the side of caution, and they halted all flights as a precaution. I saw an animation of all the flights in the United States converging and then just settling at airports and not taking off again. The impact wasn't uniform, of course. For example, the Canadian airlines don't seem to have been using Crowdstrike, so they've been unaffected. Beyond just flights, there have also been reports of hospitals being impacted, especially in the UK. Doctors couldn't access patient records, couldn't view or edit schedules, and pharmacies couldn't sell drugs. Many banks and ATMs were impacted, and supermarkets, including the one that I go to, ended up having to take cash only. Most of JP Morgan's ATMs stopped working, and American Express started having trouble processing transactions. It comes at a particularly awkward time for Australian businesses, because many of them are pushing to go cashless within a couple of months. And then they had to say, oops, actually, we only accept cash right now because everything else isn't working. The FBI and all .gov websites were impacted in the United States, as was FedEx and many news organizations, which basically went offline for hours. Even Kurtz had to stop operations, In Alaska, for example, it took 12 hours to reboot all their systems and get everything working again. So obviously the impact has been really widespread. In fact, I would say that the actual impact is not that severe, but the number of people and the number of organizations it impacted is basically unprecedented. To be clear though, other big companies do mess up. It's not just CrowdStrike that's done something like this. A favorite one for Canadians is July 8th, 2022, when Rogers had an internal DNS mix-up and then their cell phone service across the entirety of Canada was down for a whole day. On October 4th, 2021, Facebook, or Meta, had a similar issue where their internal DNS messed up and the whole site was down for 6 or 7 hours. This kind of thing can be a business killer. The phone manufacturer BlackBerry had a 4-day outage due to a server failure, starting at around October 11th, 2012. To make matters worse, it was their second outage in a relatively short period of time. So after that, all their users basically left. They went to use Apple phones or they went to use Android phones instead of BlackBerry. That was the final nail in the coffin for the parent company, Research in Motion. One last fun example, McAfee, which is also an antivirus company, brought down hundreds of thousands of systems in April 2010. What makes this interesting is a man by the name of George Kurtz was the CTO of McAfee at the time. That same person, George Kurtz, is now the CEO of CrowdStrike. So basically, he has presided over two similar looking disasters, both of which were apparently due to a lack of good quality control. And at least now, as CEO, he's rumored to have fired a lot of quality control or QA people from CrowdStrike to try to cut spending. Let's just say that every word out of his mouth right now has already gone through the legal department and gotten approval. Part 2, Under the Hood. You might wonder why I'm interested in this CrowdStrike incident. After all, I usually make AI videos on this channel. But basically, before my current role, the previous company that I worked at made products that are somewhat similar to what CrowdStrike does. I managed the component that handles auto updates, amongst other components. So I've spent a lot of time thinking about this type of problem. As I mentioned, CrowdStrike is seen as a leader in the EDR space. They're the biggest player with the most resources, and their product is the most expensive and the most valued. The second biggest player is a company called Sentinel One. CrowdStrike focuses more on lifting all the data into the cloud and doing comprehensive analysis, and they can afford a lot of manual analysts that can go and look at that data. Sentinel One relies more on algorithms and AI, which is cheaper but has more of a history of backfiring. Anyway, if you visit Black Hat, the biggest industry security conference in the world, all you see are CrowdStrike and Sentinel One ads everywhere, starting from the moment you land at the airport. This issue with CrowdStrike arose this time because of an update that was pushed to all the installed Windows CrowdStrike agents. This is a very complicated piece of code, the auto updater. It has to pull down new configuration from the cloud very frequently, sometimes even pull down new code and automatically install it and run it. And it has to solve problems like, how do you update the auto update system? And how do you deploy changes into a running operating system kernel without requiring the user to reboot the systems? Because CrowdStrike pushes updates at least once a day, and so they can't require their users to reboot all their systems. Why is the auto update system pulling down new configurations so frequently? Basically, because new malware gets discovered all the time, and the configurations contain things like, look out for this, we've seen it attack this other computer over here. If you see this pattern of behaviors, it's potentially the start to another type of attack that we think the UAE is doing right now, etc., etc. So although it seems dangerous to be auto updating a system so frequently, and it is pretty dangerous, as we've seen, that's essentially a big part of what you pay for when you are purchasing an EDR product. You want all the latest security patches from the past hour or even the past minute, if you can. So what really happened at CrowdStrike? Well, CrowdStrike has nearly all of their analysts in a few cities in India, and the update was pushed at 9:39 a.m. IST. So it may have been some new specification that had just been written out by somebody on Friday morning and then pushed out to production. But that's just speculation on my part. Like I said, CrowdStrike deploys these types of changes all the time, probably many times a day. So they weren't that worried about it. The update changed a configuration file only, a file that specified, here's what different pieces of malware look like. But something went wrong between the time that the analyst pushed the publish button, and then some computers thought about the problem for a while, and then the file was finally served to all of CrowdStrike's customers. Because the final file that was served to customers was actually a file full of all zeros. It had no content. 42 kilobytes of just zeros. By the way, the file that CrowdStrike sent out to remedy this issue was about 35 kilobytes. So it's possible that the size was expanded a little bit in addition to being set to all zeros. Again, This almost certainly happened because at some stage of the build pipeline, there was an error that had never been seen before and was not handled properly. Perhaps some process ran out of memory and crashed and didn't finish the job it was doing. That's my hypothesis, because it's fairly common actually for binary files for a program to expand the size of the file and then end up seeking to different positions in that file to write data into it. And of course, if you expand the file, then it has all zeros at the beginning until you overwrite those zeros with something else. Again, that's just a hypothesis. There are many ways that a file could end up full of zeros, but that's something that I personally have actually seen in the past. So normally, when you push production code out to the wild, especially when it's going to millions of computers, you want to push it very slowly and carefully. Run it in a test environment first, then push it out to 100 machines, then push it out to 10,000 machines, and do that really slowly. And if you encounter any issues or errors along the way, stop the rollout. Crowdstrike evidently didn't do any of these types of tests, nor did they roll out the update slowly. They just pushed it to all of their clients' machines all at once. And I can sort of understand the reasoning there, because they probably don't want to delay these updates getting to machines, because it's often the case that an attack is ongoing and they want to protect other machines as quickly as possible. But if someone had fired up this configuration change on even one Windows box and asked it to reboot, they would have seen that something catastrophic had gone wrong. What happened was that Crowdstrike had a Windows driver that was reading this configuration file. The driver started up very early on during the Windows boot process, opened the configuration file, and started interpreting some of those bytes. But they were all zeros. They didn't contain the expected information. So the driver ended up trying to dereference a null pointer, a pointer whose bytes are all set to 0. That caused the driver to crash, and Windows, the kernel for Windows, couldn't handle that crash, and so it brought down the entire kernel, causing a blue screen of death. You might wonder, how much blame does Microsoft share in all this? On the one hand, the crash was due to a third-party driver accessing a null pointer, not Microsoft code. However, accessing a null pointer is actually the #1 most common bug in drivers these days. Windows had no null pointer protection up through and including Windows 7, and since then, they've had some protection in user space, but not in kernel space, as far as I'm aware, which is where drivers run. If they haven't addressed this, it would be because it's very difficult to update the driver API and still maintain backwards compatibility, because Windows has been around for a very long time and they try not to break things because that makes their enterprise customers unhappy. Most other modern kernels, including the one in Linux and I believe in macOS, do catch null pointer dereferences and handle it gracefully. In the case of Linux, the system doesn't even halt. However, anti-malware has hooks that run at really unpredictable and weird times during kernel execution. It seems quite likely that this crash was due to a very early stage driver happening early on during the computer's boot process. So it could also potentially have affected kernels that normally handle this gracefully. Also, the change was completely invisible and undetectable to the Microsoft kernel because the same driver was running. And previously, that driver never crashed. It was just a data file that was changed, a dependency of the driver that the kernel would not have been aware of. So it would not have been possible for Microsoft to roll back the drivers to a known good state or something like that, which I have seen Windows do in the past. The driver mechanism was simply not designed for code or data that changes every day. Normally, whenever you get a driver signed and accepted by Microsoft, you have to go through a series of very stringent checks, and it can take quite a long time because Microsoft has really tried to clamp down on bad drivers. They've really tried to ensure the quality of driver code. But I guess this null pointer issue was not detected in the Crowdstrike driver when Crowdstrike applied to have their driver approved. Most unfortunate. Do you think Crowdstrike will survive this debacle? I originally thought no, because of the scope of the impact. You know, hitting 8.5 million computers when you're supposed to be the one defending those computers is a really big problem. Especially when, for example, hospitals start reporting in saying, here are the surgeries that were all canceled, and here are the patients that died because they couldn't access the care that they needed. But fortunately for Crowdstrike, the issue seems to have been reasonably straightforward for corporations to address. Once they figured out what was going on, which did take a while, it turned out that it was only a mild issue for each given computer, and you could fix it manually without even transferring any files to that system. You could even fix multiple virtual machines at once by connecting their drives to a single instance and running some fix-it script. Furthermore, the cost to switch away from Crowdstrike is probably prohibitive. So I think it depends on how much litigation Crowdstrike receives. It might be so much that they collapse under that weight, but then again, they might just be too big to fail at this point. Part 3, addressing systemic risk. When everyone is using the same systems, you basically have a digital monoculture. That is a huge systemic risk. If something happens to one system, it can happen to all the systems at once. At a high level, you can basically mitigate the problem, so if it does happen, it's not as bad, or you can diversify. You can start using multiple providers, you can start having multiple plans in place. So from a company's perspective, what can you do about this? Well, first, mitigations. The number one thing is quality assurance, or QA, and testing. CrowdStrike is rumored to have laid off a bunch of QA engineers last year. So they probably don't have enough QA going on, but it's absolutely essential for a software company that's developing the type of software that CrowdStrike is, i.e. updates that are ending up in the Windows kernel. Of course, the companies that are using CrowdStrike could also be QAing their own systems. A lot of companies very carefully apply Windows updates, for example, and they don't just let it auto-install across the whole fleet. They do it in pieces. First a few machines, then a few more, etc. But as I mentioned, the point of CrowdStrike is that all your machines get defended very quickly. So I don't think it's reasonable to expect other organizations to actually stage the deployment of CrowdStrike updates, if that's even something that CrowdStrike supports. So CrowdStrike bears the burden of QA in this case, and they apparently weren't doing any of it. I've mentioned it a few times, but another good mitigation is to do staged deployment. Send out to just a few systems, then a few more, etc. before you send out to the entire fleet, even for configuration changes. Even if you just change the color of the font on the main page, stage deployment is just a no-brainer. It blows my mind that CrowdStrike was not doing this. Simply incredible. Another pretty good mitigation is to have your infrastructure run without state. This basically means that all your servers can be rebooted whenever you want. They don't contain state, so you don't lose anything if you restart the systems. Which means that if the old systems crash or go offline, you can easily start up new ones, even in theory on new hardware or on another cloud provider. Obviously this takes time, but if the computers are in a really bad way, then it becomes more appealing to actually start over from scratch on a new cloud provider. Taking this one step further, an enterprise could actually run multiple instances of their entire ecosystem in new environments, essentially having a backup system available at all times, or a hot spare, if you want to call it that. This is not foolproof because of correlated failures. For example, if someone was running their Windows system on Azure and their Windows systems on Amazon AWS, then they would all have been taken out by this particular issue. But it can certainly help if, for example, Azure is the one that goes down because your Amazon systems can keep running. To be fully robust, I suppose you would have to have the same software running on a different stack, preferably a re-implementation of the same software, which of course is way too much effort and no one would actually do it. But there is research that makes different computers run different code when they're actually trying to run the same program. You can basically scramble the code in some way so that it's more robust against attack. This can be a useful approach, but it makes maintainability and deployment a lot more difficult because it's harder to predict, for example, the performance implications and the resource requirements of a bunch of systems when you're trying to scale up. So I don't think this happens in the real world. Beyond all these technical techniques, it's also very common for companies to simulate security scenarios. It's usually called a tabletop exercise if you're doing it just on paper and in your head and theorizing about what would happen in certain situations. It might sound silly, but tabletop exercises are surprisingly effective, so much so that it's often a compliance requirement for the company's leadership to undergo. And this particular CrowdStrike incident would certainly have been foreseeable in a tabletop exercise. What happens if we push a bad update has to be one of the most important issues that the driver implementation team has to think about. Someone should have thought through the ways that they would address this. And my guess is that someone did, but nothing was done about it, perhaps for cost reasons or because the particular scenario was considered so unlikely that it didn't deserve any mitigation, which is itself a useful finding. Pay more attention to your tabletop exercises, for instance. Remember I mentioned that CrowdStrike is seen as the #1 EDR provider in the world. And in general, software tends to be a winner-take-all scenario. There's little reason for anybody to use anything except the best product other than price. So the winner-take-all scenario is particularly true for open source software, but you see a bit more variation for commercial products. Top-tier products like CrowdStrike price themselves accordingly, very high, which helps them get so much capital that their lead is that much harder to bridge. This is a big reason why there are so many monopolies in computer software, which means that correlated failures will always have very high probability. There's not much that most companies can do about it, except follow some of the mitigations or diversification strategies that we already addressed. This whole scenario of having a monopoly on some computer software, so everybody uses it, but then having vulnerabilities in that software that lets you attack the entire internet at once. Well, this whole scenario is just attacks waiting to happen. And in the CrowdStrike case, it wasn't even an attack, it was just a mistake. But when you get clever attackers, especially attackers that are using advanced AI, they can really cause havoc. Because AI is really quite good at finding vulnerabilities, and it's excellent at writing code to actually take advantage of those vulnerabilities. Therefore, it's my guess that these types of really widespread, large-scale attacks are going to start happening more frequently, with even greater severity than this CrowdStrike incident, where instead of it being a mistake, there's an actual malicious attacker who makes off with all the data, or destroys or shuts down all the systems, and then destroys all the backups. The attacker could do this, for example, by taking control of the CrowdStrike update mechanism or the Windows update mechanism and using it to push bad code to the systems so that they don't just crash and require some manual intervention and then they're fine again, but their disks are quietly encrypted and then the attacker throws away the key. So in my opinion, there's a huge need to start applying AI to these types of problems defensively. How can AI help us deal with class breaks where someone attacks and succeeds in breaking into a bunch of systems all at once? That's an interesting and valuable research problem, if you're interested. Finally, in conclusion, we talked about an incident that CrowdStrike caused by accidentally pushing a bad update to millions and millions of Windows systems. Because CrowdStrike is usually employed by larger organizations, those systems that were impacted were actually really pretty critical ones, which is why flights were grounded, hospitals having trouble treating patients, and government websites completely shut down. Although that's very difficult, it's something that CrowdStrike has a lot of expertise at. And if they had been doing any QAing or quality assurance testing, then they absolutely should have caught this. It is mind-boggling to me that a company with the resources of CrowdStrike is not doing simple tests before they deploy to all of their clients at once. Will CrowdStrike survive this? Who knows? But it has pointed out a very important vulnerability in our critical systems, which is that when they all run the same software stack, they can all be taken out at exactly the same time. So I bet a lot of big companies right now are thinking to themselves, how can we mitigate or diversify so that these types of issues don't happen in the future? If you liked this video, check out this previous one I made about how secure the internet really is against quantum computers. Well, that's all I have for today. Thank you very much for watching. Bye.